The Combustion Solar Energy Lab is led by Dr. Miller. This lab provides research space for projects involving flammability testing and solar energy conversion. Undergraduates working on senior design projects and graduate students have helped outfit this lab with several pieces of unique equipment. The standard NASA test is a flammability test rig constructed to measure the burning rates of various materials to be used aboard spacecraft, such as composites and fabrics. The alternative test developed at SDSU utilizes a wind tunnel to simulate microgravity flames by manipulating the flow through the tunnel. Materials tested include acrylic, circuit board material, beverage pouch material, polyester, Kapton film, astronaut suit material, and human hair. A thermal camera is used to record the flames through a quartz crystal window. The solar simulator is equipped with a 15 kilowatt arc lamp source. The lamp is used to simulate radiation from the sun. The source can be manipulated by placing additional lenses to focus the light and adjust the power. 3 5 kilowatt power supplies provide the necessary power for the lamp. Led by Dr. Wood, the Interface Design Laboratory is focused on developing and disseminating cutting-edge research in the areas of renewable energy, electrochemistry, and corrosion prevention. The Interface Design Lab provides undergraduates the opportunity in research and sponsored capstone projects. The X-ray photoelectron spectroscopy measures surface material composition via the photoelectric effect. The installation of this machine was assisted by an undergraduate student. The student performed baseline tasks for benchmarking and developed machine operating procedures for general use. This cold spray system was developed as a senior design project with a graduate student consultation. The system was developed with a budget of just $40,000. The system is currently being used to investigate protective coatings for batteries. These battery test cells are designed with an observation window. A camera is positioned over the window to observe defect formation such as dendrites. The high-resolution camera can produce images with defects as small as 1 micron. As defects form and progress, the camera position and focus needs to be adjusted. This automated adjustment system was designed and built for a senior design project. The Powder Technology Laboratory, led by Dr. Oleski and Dr. Torsani, is equipped with sintering furnaces, pressing equipment, analytical instruments for material characterization, VIS 300-01A microwave sintering system, a spark plasma sintering machine, SLS printer, circular tube furnace, and other state-of-the-art equipment. This sintering furnace was modified into a hot press furnace for a senior capstone project. The sintering furnace alone is capable of sintering at a specific temperature but lacks precision pressure control. The senior design team modified the furnace so pressure is applied by an Instron testing system. The furnace can be easily installed and removed from the Instron with the aid of a modified hand winch. Included with the final product is a procedure for operating the system and detailing safety precautions. Such projects increase the capabilities of SDSU lab facilities while providing students with valuable engineering experience. The Flames, Aerosols, and Nanoscience Laboratory, or FANS Lab, is run by Dr. Camacho. The FANS Lab includes flames and other high-temperature processes that are used to synthesize nanomaterials and develop device fabrication methods. The spray carbon chamber is used to synthesize carbon black. The system is supporting many current and planned undergraduate projects, including a filter to collect particles, particle sampling and analysis, a thermocouple system to measure temperature, and design of a nozzle to test spray. Such projects provide students with hands-on experience and enrich the testing abilities of the system. The lab is also equipped with 2 smaller carbon spray chambers, one of which exhibits a telescopic stage that was created for a senior design project. The second system isolates flames for reaction studies by creating a sheath of nitrogen around the flame. This allows for a focus on the chemistry of the reaction flow by isolating the flow for study. The setup also facilitates ease of experimentation and imaging. The system is currently being utilized for the summer undergraduate research program. The Bioengineering Lab, led by Dr. May Newman, serves as both an instructional and research laboratory. 2 workstations equipped with BioPack instructional lab systems provide hands-on experience for students enrolled in the upper division biomechanics course. Undergraduate students also have the opportunity to work on research projects in the area of cardiovascular biomechanics, biomaterials, and medical devices. Heart simulation starts with a process of making thin silicon bags using a drip molding process. A wax mold of the left ventricle is created by dipping the silicon, creating a 0.5 millimeter thin transparent layer. Ongoing testing of this process includes variation in the formula and curing time. The silicon molds are then tested using a stepper motor to oscillate pressure or a pneumatic system to oscillate pressure. Both of these systems are used to simulate heartbeats. The major experimental research in the laboratory is the SDSU cardiac simulator, an in vitro flow circuit that simulates the circulation of a patient implanted with a left ventricular assisted device. An LA Vision DPIV camera laser software system is then used for measuring both strain and flow through the in vitro flow circuit. The Mechatronics laboratory is led by Dr. Moon. Research in the Mechatronics laboratory focuses on smart sensor and actuator technology, as well as brain-computer interface technology. Other prototypes, such as a 3D printed helmet, helps realize cost-effective brain interface alternatives. Prototypes, such as the robotic walker, provide walking assistance via an EKG brain interface helmet. The Mechatronics lab also houses a scanning electron microscope. As part of summer research in ME49, undergraduates learn how to use the scanning electron microscope and participate in research led by Dr. Moon. The Energy Research Laboratory, located in the Engineering and Interdisciplinary Sciences Complex, has a low-speed wind tunnel. The focus of the research work in the laboratory is on alternative energy, including design, materials, and testing of morphine wind turbine blades, solar energy, and combined heat and power systems for low-grade energy recovery. In addition to the wind tunnel, the laboratory is equipped with power meters, flow meters, RPM meter, DAS, a combustion analyzer, and other thermal equipment. The laboratory has locally networked computers with access to CFD and energy simulation software. Equipment in the laboratory is used for senior design projects and undergraduate independent research projects. The MEMS Nanofabrication Lab, located in EIS 110, is operated by Dr. Kisinj. This laboratory contains an ABM high-resolution mask alignment and exposure system, SVGL ASML microscan deep UV lithography station, Cymer EX5700 deep UV laser system, PECVD and pyrolysis split tube furnace with vacuum system, OAI UV light source, acid etching, wet and dry oxide growth, Brewer's spin coater, ETS 150 thermal evaporation and sputtering, and Technics Series 85 plasma etcher. The MEMS Fabrication Laboratory supports undergraduate students during the summer research program and ME 499. Students can participate in various groups such as the Neuro MEMS group, the Bio Nano Electronics group, the Polymer Solar Cell group, Microfluids group, and Computation group.